Special area types in OSPF. We start with a word of caution. What's one of the reasons that students struggle with these special area types so much, I think? It's because they have not done the initial prep work that they should do in order to master this topic. They gloss over the LSA types that we have spent so much time with here in this route course. Type 1s through what? Type 5s, and they do something special, each one of them, and they really don't do the hard work that is required with those very important LSA types. Once you do that hard work, once you understand the different types of link state advertisements that OSPF will use, now you can really start to dig in and enjoy the discussion and the study of these special area types that we have in OSPF. Let's review a couple of our classics now. We know the backbone area. OSPF Area 0, and we've been working with that. We've also been working with normal areas. In our examples here, it's been that Area 54 that we created. That was just a wonderful, normal OSPF area. To this discussion now, we are going to add 3 types of special areas in OSPF. We'll see their configuration. We'll see exactly what they do to the OSPF operational processes and why we love them so much. First, the stub area. In this particular area, we're going to see where we can reduce the amount of information in the OSPF database by eliminating type 5 LSAs from that area dynamically. The totally stubby area. This is what I used to be called in high school, by the way. But this totally stubby area we're going to see is going to filter out, as its name implies, even more prefix information from the OSPF database. We'll see it's going to work on not only type 5s, but type 3s as well. And then the not-so-stubby area. We'll see how the not-so-stubby area is going to allow for some redistribution of prefixes through it into the OSPF domain. There's even another one that we'll discuss, and this sounds like a great example of an oxymoron, kind of like jumbo shrimp, but there's the totally not-so-stubby area, believe it or not. And the totally not so stubby area is something that we'll look at in this presentation as well. So we end up devising a scheme whereby we are creating special areas in the OSPF domain where appropriate to reduce overhead, to reduce processing power required on these particular devices. We might obviously have normal areas, but we'll have stubby where appropriate, stub where appropriate, not so stubby. We can even see an example of what I was mentioning a moment ago, that totally not so stubby area in our particular topology. Remember, our LSA types here are critical when it comes to these special areas, and we'll be reviewing how the special areas are going to dynamically filter on certain LSAs when we create them. Now, there are some overall rules here that these really cool looking soldiers are going to enforce, by the way. So there are some very important rules. Okay. When it comes to creating these stub or totally stub areas, we want to ensure that we've got our area border router, of course, because the area border router is going to be that critical enforcement point for the particular special area. Notice that all of the routers need to be configured for that special stub area designation. You probably remember this from back when we were discussing OSPF adjacencies. In order for devices to become adjacent, we pointed out how those devices would need to have matching stub flag designations. Well, sure enough, in order to form this special area type, they all must be configured with the matching stub designation. For the stub or totally stub, we can't have an ASBR. Yeah, the autonomous system boundary router wouldn't make sense in those particular areas because, as you're about to see, in those particular areas, we're going to be filtering out Type 5 LSAs. Obviously, the stub or totally stub can't be area 0, and this one's interesting, we can't have virtual links go through that area. You remember our discussion of virtual links where we had a particular area that was not connected to the backbone, and we had a temporary fix or band-aid for that situation where we would essentially tunnel area 0 out to that area that's not connected to area 0 and repair the broken design. Well, virtual links are not allowed through these stub or totally stub areas. So if you ever did have a design with a stub area and some other area that you needed to do a virtual link with, you'd have to go ahead and do something like a GRE tunnel. You'd have to be creative yourself with tunneling because a virtual link would not be an option in that particular design scenario. So let's go ahead and jump in here. Let's talk about stub areas. What happens with the stub area? Well, as you can see from this awesome diagram, we've got some external Type 5 prefixes up here. Heaven forbid our OSPF domain connects to a RIP domain. Yikes. So there's our autonomous system boundary router, and it is taking in these Type 5 LSAs, and it is sending them out into the various areas. Sure enough, here we can see Area 51 is standard, so the Type 5 LSA types, notice they go right into that area, no problem. But notice here on this area border router, which sits outside a special area called Stub, here the external Type 5 LSAs are not going to propagate. They'll be filtered dynamically thanks to this special area called a stub area. How cool is this? Dynamic filtering of our LSAs. But wait a minute. How in the world are the happy little routers in that stub area, how are they going to get to the prefixes that are being advertised by the ASBR? Well, OSPF takes care of that for you. Instead of sending those Type 5s into the stub area, what does OSPF do? It sends in a default route. It dynamically sends in this default route so those particular devices will indeed know how to get to the external LSA 5s that got filtered. This is pretty amazing. In fact, I don't believe it. I don't believe this will work. I absolutely want to see this work for myself. So we're going to go up and we're going to take a look at this at the command line, and we're going to verify that Cisco's not pulling a fast one on us here, and this will actually work. Okay, now you remember what we had for a topology, by the way. We had area 0 up here. We had the ABR on R5. We actually brought in some external prefixes into this area 54. Let's go to this area 54 and let's stop the ASBR functionality. So we'll go ahead and take area 54 and we'll just really revert it to a plain old regular area. And we'll stop the default route generation that we did over here on R2. And then, as you might guess, what we want to do is we want to take this area 54 on the left and we want to make it a stub area. And we'll see if everything we just learned about is indeed true. All right, so the first thing I'm going to do here on R6 is I want to undo the ASBR functionality on R6 that we saw earlier. So I'll just say this. I'll say no router EIGRP 100. We will rip out the EIGRP. What that's going to do is rip out the type 5s that are learned on this particular device and all others from that external autonomous system. Great stuff. Now, one other modification I want to make to our topology, as I indicated, is I want to go over to R2 and I want to do show run include, let's see, let's do show run section and look at OSPF. What I want to do over here in R2 is get rid of the default information originate always command that we utilized in an earlier demonstration. So we'll negate that. Okay, that's gone. All right, great. Now let's pop back over to the R6 device and let's do show IP OSPF database. What I'm expecting to see here in the database, and aha, it worked, is we have absolutely no more type 5 LSAs in this particular database, do we? Wait a minute. We do have one. It's the type 4 LSA because of the redistribution command that we are utilizing. Let's go ahead and undo that as well. Router. So that's a type 4 that we just saw in the database. You can see the type 5s are gone. We're going to say router OSPF 1, no, redistribute EIGRP 100. And that should get it done. Do show run section OSPF. All right, here we go. So the redistribution should be gone. It is. We'll end and save. And now we have the topology the way we want it, but there is something that we would like to do here. To demonstrate the stub area, what I'm going to do is I'm going to go up to R4. I'm going to create some networks, and I'm going to make them part of EIGRP. So what we're going to do is we're going to create another, type 5 LSA situation. We're going to create an ASBR out of R4, and we're going to see those prefixes in area 54. And then we'll be ready to test our stub behavior. All right, let's do it. We're going to go over to R4, and here we go. We're going to go interface. Oh, let's see what interfaces we have. Do show IP interface brief. All right, we've got not much going on here, so I'll say interface loopback 10. Oh, we already have one. How about loopback 20? IP address 40.40.40.4. Interface loopback 21. Let's do the 50/50 subnet. And we'll do one more. Interface loopback 22. And we'll do the 60 subnet. Okay, here we go. Router, EIGRP 100, network 40. And we'll say router OSPF 1, redistribute EIGRP 100 subnets. Again, we'll be covering redistribution in great detail later on in this course. Okay, we just did it. We've got the topology pretty well set up now in order to play with this feature. If we go back to R6 in Area 54, and we take a look at show IP route OSPF, for example, sure enough, this area is taking in the external type 5 prefixes. If we look at this in the database, we'll see it. Show IP OSPF database. Yeah, we can see we have the type 5 LSAs. We can see that we have an ASBR reported now. And the ASBR, of course, is up there on the R4 device. So sure enough, this particular device, R6 in Area 54, is being subject to all of the external prefix information. Does it have a default route now? No. There is no gateway of last resort set. We notice when we look in this routing table, it's getting pretty large for our little lab topology, we can see there is no default route information. What does the stub area do? How does that stub area behave for us? We said what should happen, according to Cisco, is that stub area is going to dynamically filter out the type 5 LSAs, and the stub area configuration should automatically inject a default route so these happy little stub routers can get to those external prefixes that are now dynamically summarized. I'll believe it when I see it. All right, let's go ahead and engage in the stub configuration. You ready? We go to the area border router. Remember, the area border router here is our R5 device. And we're going to go to this R5 device, configure it for stub, and then remember, everyone in Area 54 needs to be configured for stub, so we're going to do that on the R6 device as well. First, the area border router. Watch how easy this is. Router OSPF1, Area 54, congratulations, you're now a stub area type. And bang, we have a failure of the adjacency between R5 and R6 because, as we learned earlier in the course, they have a mismatch in their stub flag designations in the hello packets. Designations? I've never pronounced it that way before. Here we are in R6. Router OSPF1, Area 54, stub. We expect the adjacency to heal, and it does. Hey, look at this message that we got when we tried this. OSPF 4 ASBR without valid area. Router is currently an ASBR while having only one area, which is a stub area. Oof. This R6 still thinks it's an ASBR from our earlier configuration. It's not, though, and I suspect that error is now solved because we can see our adjacency has come up. We'll end our configuration and we will test this stub behavior. Let's do our show IP route OSPF command. And look at this. It worked, and it worked like a champ, as they say. We have lost all of the external prefixes that were coming in from that R4 ASBR that we set up. All the externals are gone. And in their place is the automatically generated default route. Wow. Let's go ahead and look in the OSPF database. Show IP OSPF database. Look at this. Amazing. We've got our type 1 LSAs for Area 54, our type 2 LSA for Area 54, our type 3 LSAs for Area 54, including the default route, which is a special type 3 that got injected by this feature, and our type 4s are gone, and our type 5s are gone. thanks to the special area type known as stub. Very, very cool. It not only works, it works just like we were promised that it would work. But I want to go a step further. Yeah, I want to go a step further. What about all of these prefixes? What if I want to eliminate those from the database and therefore from the routing table? Well, this is where we need, dun dun dun, the totally stubby area. Yeah, why don't we take not only these type 5s from that yucky RIP domain, why don't we not only dynamically filter those, but why don't we dynamically filter the type 3 LSAs as well? Why don't we just really rely on the default route to get us to every remote destination, both the internal OSPF prefixes and the external prefixes? This, my dear friends, is what a totally stubby configuration is all about, and you are not going to believe how easy this is to configure. All we have to do is go to our area border router, which is where we initially configure this, and we just modify the configuration right there, ever so slightly. This slight configuration modification ends up having a dramatic effect on OSPF's operation. Watch how we configure the totally stubby operation. We go to the area border router and we say router OSPF1 area 54 stub. That was exactly what we did before, but now we say no summary. Please note, this only has to be done on the area border router. All the other routers in the stub area do not need the no summary keyword. Notice nothing appeared to happen. We'll end and we'll pretend we're in the exam environment. We'll do a copy run star to save our configuration. This is pretty amazing. Again, nothing on the surface here appeared to happen or change. But if we go down to R6 and we rerun our show IP OSPF database command, holy prefix filtering, Batman. We did have a major change, didn't we? All of our type 3s are gone, except for the special default route type 3. If we do our show IP route OSPF, we can see the database, the forwarding database, has been remarkably simplified. And of course, thanks to the default route, we still have the ability to get to every destination. Can we get to a external prefix? Sure we can. Can we get to something that lives in the OSPF domain? A type 3? Well, sure we can. We can get to everything that exists in and outside of our domain thanks to the automatic injection of the default route. Awesome work, everyone. Now, let's discuss the not-so-stubby area. In the not-so-stubby area, we want to take advantage of the stub area functionality. We want to be shielded from things like type 5s, okay? But we do have a special little requirement. Interestingly enough, we do have some external prefixes that we want to bring in through the stub area. Thus, the very appropriate name, Not-So-Stubby Area. Yep. So we're going to inject some prefixes in. Notice this is what the special type 7 LSA type is for. Yeah, this is what that special LSA type is for. We're going to bring these external prefixes through the not-so-stubby area as type 7s, and the area border router will pick them up and convert them to regular old type 5s and send them into the other areas. So notice the type 7 LSA is a special LSA type just for the transport in the stub area of those external prefixes. Once they make it through the special type 7, once they make it through that area and move into the areas beyond, then those particular prefixes will be converted dynamically to the regular old type 5s. Now, you probably want to see this demonstrated, and I demonstrate this for you in a nice supplemental video that I've created for you up at YouTube. So just head on up to YouTube, and when you get up to YouTube, just do a search on, you ready for this? OSPF LSA Type 7. Yep, OSPF LSA Type 7. And you'll see my video first on your list, and just go ahead and select this particular video. And it's a nice, succinct 5-minute presentation that I go through. Boy, I look mad. I was mad that day. Very, very angry. So anyways, I just go through a quick demonstration for you on the LSA Type 7. So check that out. Just trying to imitate myself there. Okay. All right. So check out that demonstration. I think you're totally comfortable now with the Type 7, what it's used for and everything, but check that video out so you can see it in action. By the way, a totally not-so-stubby area? Well, here's where we're using the no summary keyword with the not-so-stubby area configuration, and sure enough, we are blocking the type 5s, but we're also blocking the type 3s again, and we're still able to inject these external prefixes into that area utilizing the special LSA type of 7. So pretty cool. Here is a look at the NSSA configuration. So here's how we do our not-so-stubby area. Here's how we do our totally not-so-stubby area. And as you might guess, it is very simple. We're just adding the no summary keyword again, following the manner in which we did the stub and totally stubby areas. So very, very simple once you have mastered those particular stub and totally stub. The not-so-stubby and the totally not-so-stubby are absolutely simple indeed.